All right, so final exam time. Okay, so number 1, it says graph the triangle ABC with vertices. So let's go ahead and just graph those vertices. So A is 4, 4, so I'm going to go over 4, up 4. B is 3, -2. And C is -1, -1. So there's my triangle ABC. It says then graph the image of ABC reflected in the y-axis. So here's the y-axis. So I'm going to reflect over the y-axis. So here I'm just going to count. This is 1, 2, 3, 4 from the y-axis. So I'm going to go 4 to the left. 1, 2, 3, 4. And there's A prime. Then I'll do the same thing for C. Well, here we'll start with B. Is 1, 2, 3. So I'm going to go 1, 2, 3. And there's B prime. And then C is just 1. So I'm going to go 1 the other way. And there's C prime. So there's our triangle reflected across the y-axis. Number 2, what is the image of -4, 7 under the translation? So here you can just add and subtract these. So I can go -4 plus 3, and 7 minus 5. So that would be -1, 2. Number 3, find the image of CD. So 0, 4, let's go ahead and draw that, is C. And 3, 4 is D. So it says under a 90-degree counterclockwise about the origin. So first of all, let's think counterclockwise. If I'm on a clock, I'm going to go around this way. So counterclockwise, I'm going to rotate this way. So I'm going to rotate it 90 degrees. And now I'm going to count from the origin what those points would be. So I'm going to write over here C. I go left 1, 2, 3, 4, and I don't go up or down. So that's going to be -4, 0. And D, I go left 4 and up 1, 2, 3. So -4, 3. Now I'm going to turn it back around and I'm going to graph those points. So -4, 0 is C. And -4, 3 is D. So there's the new, there's the old, and there's the new. Number 4, if A prime, B prime, C prime is the image of ABC under a dilation, what is the scale factor? So scale factor is new over old. So the new one is the small one here. So 1, 2. And the old one is this one. 1, 2, 3, 4, 5, 6. And that reduces to 1/3. Number 5, which set of triangles could represent the sides of a right triangle? So here we could just check which ones work for Pythagorean theorem. So I'm just going to plug some of those into my calculator. So 2 squared plus 3 squared does not equal 4 squared. That's 16. 7 squared plus 11 squared is 170, and I want to see, does that equal 14 squared? No. 8 squared plus 10 squared, does that equal 12 squared? No. 9 squared plus 12 squared, does that equal 15 squared? Yes. So this one represents the sides of a right triangle. Number 6, the geometric mean for A and B is found by the formula. Find the geometric mean between 3 and 27. So all we're going to do is fill in A and B, and we're going to solve. So we're going to cross multiply. So x squared equals 3 times 27 is 81. And then to solve for the x, or get rid of the square, I'm going to square root. So x equals 9. And number 7, the length of the sides of a square is 10 meters. Find the length of the diagonal. Okay, so here's a square. And says the sides are 10, but we want to find the length of the diagonal. Well, this is a 90-degree angle, so I can just do Pythagorean theorem. So 10 squared plus 10 squared equals 200. And I want to square root 200. Now, if you put square root 200 in your calculator, you get some crazy decimal. So some of you who don't remember how to simplify your radicals, you could put those in your calculator and see which one gives you the same answer. So I put 10 square root 2 in my calculator, and it gave me the exact same answer. Okay, number 8. Find x in ABC. So it looks like it's a right triangle. You can do a couple things here. You can do sine, cosine, tangent, or some of you know your 30, 60, 90 rules. I'm going to do, let's see, I've got the hypotenuse. If I go from 60, I've got opposite. So I'm going to go sine 60 equals x over 50 and multiply by 50. So 50 sine 60. I got 43.3, so I know it's not F or 100. I'm going to put these in my calculator. So 25 square root 2 and 25 square root 3. I got 43, so it's H. Number 9, find x to the nearest tenth. So same thing here. Look at my angle. I've got opposite and hypotenuse, so I'm going to use sine. So sine 36 equals x over 10. Multiply both sides by 10. So 10 sine 36. This one's tricky, 5.877. That rounds up to 5.9. Number 10, find the angle of elevation of the sun when a pole, so let me draw a pole. The pole is 25 feet tall. It casts a shadow that's 42 feet long. And it wants, oh, that's a crooked line. It wants the angle of elevation, so it wants this angle right here. So I have opposite and adjacent. So I'm going to do tangent of my angle, let's call it x, equals opposite over adjacent. Now this is where you use tan inverse. So we're going to do tan inverse 25 over 42. So you say second tan, and I got 30.8. So to get that again, you just press second tangent, and it'll give you tangent inverse. Number 11, the circumference of a steering wheel of a car is 20 pi inches. What is the radius? So circumference is 2 pi r. So I'm going to set 2 pi r equal to 20 pi. And I want to divide by 2 pi to solve for r. So the 2's cancel, the pi's cancel. R equals 10. Number 12, find the equation of a circle whose center is at 0, 0 and a radius of 6. So our equation, x squared plus y squared equals r squared. I don't have anything to plug in for the point. I'm just going to do x squared and y squared, and then this would be 6 squared, which is 36. So J. Number 13, points x and y lie on circle P. So let's draw a picture here. So this is P, x, and y. So px is 5, and xpy is 90. Find the length of xy. So we're finding arc length here. This is going to be on your formula chart. So a couple things on your formula chart. You'll have sine, cosine, tangent. You'll have the circumference formula. You'll have the equation of a circle. And then you'll have arc length. So let me show you arc length here. Sorry, ignore my handwriting. But so arc length, we're going to do arc length on top. So that's what we're going to find. So we're going to say x over, and then it's circumference. So circumference is 2 pi r, and they gave us that the radius is 5, equals the degree measure of the arc, which was 90. So the degree measure is this angle here, over the whole circle. So all you're going to do now is cross multiply. So I'm going to multiply these two together. So 90 times 2 pi times 5, and divide by 360. 7.85 meters. Number 14, in circle A, BAD is 110. Find the measure of DE. Okay, now this is different. This is arc measure. That's the easier one to find. It just matches the angle. So if this is 180 here, then this is 70, which means this is also 70. Number 15, find ABC. So if this is 120 and 100, I can find this arc here by subtracting from 360. So this is 140. And then you're going to have your circle formulas. So this one right here tells me that this angle is 1/2 of this arc. So if this is 140, I'm going to do 1/2 of 140. Which is 70. Number 16, PQ. Okay, so it's telling us these are all tangent. It wants us to find RS, so this whole thing. This is the hat theorem. So if it's tangent to this circle here, then this is also 8. So if this is 6, then this is 6. This is 7, then this is 7. So then I can just do 7 plus 6 equals 13. Okay, number 17. Look at that one. In circle O, AB equals 10 centimeters, so this whole thing here. OE is 2. OF is 2. Find CF. So it wants us to find this right here. Well, if this whole thing is 10, then this whole thing is also 10, and so then we can just do 10 divided by 2 is 5, so 5 centimeters. Number 18, determine whether the quadrilateral is a parallelogram. So it is a parallelogram, so let me cross off the nose here. And the reason it is because in a parallelogram, opposite angles are congruent. So like 134, 134, and then 46 and 46, so J. Number 19, the measure of QPS. Oh, find QPS. So it wants us to find this right here. Well, in a square, since it is a square, we know that all the angles are 90 degrees, and then the diagonal bisects it. So 90 divided by 2 is 45. Number 20, choose the true statement about trapezoid A, B, C, D. So things we know about a trapezoid. This is not isosceles, so all of the angles are different. So we don't know that the angles are the same, which is actually all 3 of those. The one thing we do know is consecutive angles are 180 degrees. So either A plus D, D plus C, C plus B, B plus A are 180. Number 21, find X so the quadrilateral is a parallelogram. So we just said opposite angles are congruent. So we're going to set these two equal to each other and solve for X. So I'm going to add 12 over. So 2X plus 72 equals 4X. And I'm going to subtract the 2X. So 72 equals 2X, divide by 2, and X equals 36. Number 22, for the trapezoid JKLM, A and B are midpoints. Find AB. So this is called a median of a trapezoid, and that formula will be on your paper, your formula paper. So it's 1/2 times the top leg plus the bottom leg. So 1/2 times, the top leg is 19 plus the bottom leg is 27, which is 23. Again, you'll be given this formula for median. Okay, number 23, find the area of each figure. All right, so we've got a rectangle and we've got a triangle. So a rectangle is easy. It's just base times height. So 9 times 15, which is 135. And then our triangle is base times height divided by 2. So the base of the triangle is 9. And the height of the triangle, they gave us this whole thing as 27. So I can, let's get that out of the way. So I can subtract the 15 to get the height of the triangle is 12 and divide by 2. So 9 times 12 divided by 2 is 54. and I'm adding these together. So 189 centimeters squared is area of that whole figure. 24, so we're going to do area again. So I've got a rectangle and I've got a semicircle. So a circle is pi r squared. I'm going to divide that by 2. Now I don't know the height of the rectangle here, but I could find the radius. So I'm going to take 6.6 divided by 2. So the radius of the circle is 3.3, which means this is also 3.3. So if I take 14.3 and subtract this little part, the height of the rectangle is 11. So area equals 6.6 times 11, which is 72.6. And then the circle, area equals pi times, we found the radius was 3.3 squared, and I'm going to divide by 2. So we'll say 17.1, and I'm going to add those two together, which is 89.7 meters squared. 25, find the area of a regular hexagon with side length of 15 centimeters. So area of a hexagon is apothem times perimeter divided by 2. They kindly gave us the apothem, that's nice, 13. The side length is 15, and it's a hexagon, so that's 6 sides. So I need to multiply 6 times 15. So 6 times 15, I got 90, that's perimeter. Divide by 2. So the area is 585 centimeters squared. Number 26, find the area of the parallelogram. So area of the parallelogram is just base times height. We have the base is 7.5. Make sure you don't use the 6 because the 6 doesn't go all the way across. And I need to find the height. Now this is 45, so you could do sine 45 equals opposite over adjacent. Oh, sorry, tangent. Here we go. Let's use the right one. Tangent 45. And you could find what it is. Some of you might know a 45 has the same side, so this is also 6. So the height of the parallelogram is 6. So if I multiply these two together, area is 45. Number 27, find the area of the figure. So remember, you're going to have all these formulas. So let's plug in area of a trapezoid is height times base 1 plus base 2 divided by 2. They gave us the height. So then we have 16 plus 20 divided by 2, which is 180 yards squared. Number 28, find the shape resulting from the cross-section of a sphere. I think most of you would know that one is a circle. 29, find the total surface area of the regular pyramid. All right, so on our formula sheet, we've got all of our surface area, volume. So surface area of a pyramid is perimeter times slant height divided by 2 plus the base. So it's a regular pyramid, which means all the sides are 11, and there's 4 sides. So 44 times the slant height, 12, divided by 2, plus, this is area of the base, so that'll be 11 times 11, which is 121. So if I plug all that in, I get 385 feet squared. Number 30, find the total surface area of the prism. So surface area of a prism, perimeter times height plus 2 times the base. So the perimeter of the base, I'm going to go with this bottom one. So 9 plus 9 plus 5 plus 5 is 28. And the height is 6 plus 2 times the base. So now I'm going to do 9 times 5, which is 45. So multiply all that together. 28 times 6 plus 2 times 45 is 258 feet squared. Number 31, an aquarium is 18 inches long, 18, 8, and 14. Rocks are added so the water rises to 4 inches. Find the volume. So volume of a prism is base times height. So the base is 18 times 8. Now for the height though, I'm going to use what the water rose to. So multiply all that, 576 inches cubed. Number 32, the ratio of the heights is 7 to 9. Find the ratio of their volume. So volumes we do cube, so 7 cubed to 9 cubed, which is 343 to 729. 33, a cylinder has a radius that is 4 inches long. Find the volume of the cylinder. So volume equals base times height. The base is a circle, so pi r squared times the height. So 9 times 6 pi, 452.4. Number 34. The cone is 9 centimeters deep and 4 centimeters across the top. Now be careful there. That's across the top, which means the radius is just 2. A single scoop of ice cream is 4 centimeters in diameter, so same thing there. Radius is 2. Is placed on top of the cone. If the ice cream melts into the cone, will it fit in the cone? So let's do volume of a cone is base times height divided by 3. The base is a circle, so pi r squared times the height divided by 3. This is the cone is 37.7. And then the ice cream is a sphere, so we're going to do 4/3 pi r cubed. And multiply that, which is 33.5. So yes, and we'll say 33.5 is less than 37.7. Number 35. We have a square pyramid, and they want us to find the volume. So volume of a pyramid, base times height. It's 8 centimeters long. Oh, that's the height. The base has sides that are 9 centimeters long. So that's just going to be 9 times 9 times 8, which is, oops, square pyramid. Should be A. Oh, I know why. Sorry. I messed up the formula. It should be divided by 3. There we go. 216. Sorry about that. Okay, and 36. A beach ball has an 18-inch diameter and a kickball has a 12-inch diameter. What's the difference of the two volumes? So we're just talking about a sphere here. So 4/3 pi r cubed. So the beach ball would be 4/3 times 9. Make sure you divide that. Radius is 9. And the kickball radius would be 6. So the kickball, 904.8. So I'm just going to subtract. And I got 2,148.8. And the last page, number 37, find the amount of leather needed to cover a ball. So if we're covering something with the ball, that's surface area. So surface area of a sphere is 4 pi r squared. So 4 pi r, the radius is 11. So 1,520.5 centimeters squared. 38, find the total surface area. So surface area of a cylinder, 2 pi r h plus 2 pi r squared. 2 pi times 2 times 4 plus 2 pi times 2 squared. 2 pi plus 2 pi times 4. 75.4. 39, find the probability that a point on the grid chosen at random lies in the shaded region. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the total is 100. Let's do the shaded. So that was 10, 11, 12, 13. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So probability is area of the shaded over area of the total, which is 0.55. Number 40, determine whether the pair of solids are similar, congruent, or neither. Okay, right off the bat, you should see that they are not congruent because they're not exactly the same. So to determine if they're similar, we're going to do proportions here. So 13.5 is the height over the height of the other one, and I'm going to divide that. I get 1.25. I'm going to do the same thing with the radius, so 16 over 12.8. I got 1.25. And then the length of the base, 12.5 over 10, 1.25. So because all those are the same, then yes, they're similar. And 41, find the probability of the spinner landing on the pink sector. So again, this is shaded over total. So this is the area we want. So we're going to do 60 over the total 360. And that's 0.17.